These are the solutions from the worksheet that we had in class today. So problem number 1 is a simple question of a limit as x goes to infinity. So all you have to do is look at the highest degrees, and it's 2 in the numerator and 2 in the denominator. So if it's the same, then all you have to do is take the coefficients. So it's -1 over 1, which is just -1. Okay, for number 2, you want to first try substitution, and if you try to substitute 3 in the denominator, you will get 0. However, you can factor the denominator. And when you do, the x minus 3's cancel. And then you're just left with 1 over x plus 1. And 1/4 was the answer. Okay, for number 3, you were given this. And you need to recognize this as a product rule. It's this piece times this piece. Okay, so the derivative is going to be the first. Okay, this one is the first. This one is the second. Times the derivative of the second. Well, the second is going to require a chain rule. So bring down the 3, keep the inside. 3 minus 1 is 2, and then the derivative of the inside is -1. So it's the first times the derivative of the second plus the second times the derivative of the first, which is just 4. And if you look at all the choices, that's not a choice. We have to clean this up a little bit. So I'm going to multiply this 3 with this -1. And now I'm going to factor out 1 minus x squared, because this is one term, this is one term. And in each term, hopefully you're going to notice that there's a 1 minus x and a 1 minus x. So we're going to actually factor out a 1 minus x squared. Okay, when we do, we're left with a -3 and a 4x plus 1 from that first term. And from the second term, we're left with a 4 and a 1 minus x. Okay, now we can simplify the inside quite easily. We get -12x. I'm just distributing this -3 minus 3. And then we're going to distribute this 4. And now when I simplify, I can combine a -12x and a -4x, which is -16x. And I can also combine a -3 and a +4, which is just 1. And that was choice C for number 3. Okay, for number 4, so we're supposed to find f prime of 1, and typically you'd find the derivative and then you substitute in 1, but when you take the derivative, you should get 0, because pi cubed is just a constant. The derivative of a constant is 0, so there's no way or nowhere for you to plug that 1 in, so the answer is just 0. That's a nice simple one. Okay, number 5, and then so it's 5 and then number 1. Okay, this is not in the correct form, so you're going to change radical x to the 1/2. Okay, so that's what you're working with. Okay, so this is a simple power rule. You're going to take that 1/2 and bring it down and multiply it by 4. So 4 times 1/2 is 4 halves, which is just equal to 2. Keep the x, and then 1/2 minus 2 halves is a -1/2. If you wanted to simplify that, that gives you 2 over radical x. Okay, so this is part 5, number 2. Okay, you have two choices here. Either the first one is, of course, going to just be 4x to the 1/2. But the second piece, you have two choices. You can either change it to 4 radical x all to the -1, and then change that radical x inside to x to the 1/2. Or you can make it 1/4 x to the 1/2. I think that's the easier one to deal with, so that's the one I'm going to show you. Okay, so we have 1/4, and then we have a radical x down below, so it's going to be x to the -1/2. And each of these is just a power rule. If you made it this whole denominator over here to the -1, you're going to have to deal with a chain rule, and that could be very annoying. Okay, bring down this 1/2 and multiply it by 4, so you're going to get 2x to the -1/2. Now you're going to take this -1/2 and multiply it by -1/4. So you get positive 1/8x, and then this -1/2 minus 2/2 is a -3/2, and that was the answer. Okay, part 5, number 3. This is just like what we did before. The derivative is just 0, because that's a constant. Okay. Number 4. Okay, this is definitely a product rule, because it's this times this. So it's going to be the first times the derivative of the second, which is just 1. And you don't even have to write that 1 if you don't want. Plus the second times the derivative of the first. Okay, and that was it for that one. Okay, number 5. So this is definitely a quotient rule. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That's it for number 5. For number 6, it was this. Okay, so this is a bunch of stuff in parentheses to an exponent, so this is going to be a chain rule. Bring down the 3, keep the inside. 3 minus 1 is 2. Now you need the derivative of the inside, which requires a quotient rule. So it's going to be the bottom times the derivative of the top, and again, you don't have to write the 1 if you don't want to, minus the top times the derivative of the bottom, all over the bottom squared. Okay, that's number 6. Okay. Number 7. Okay, there's many ways to do this problem. I'm going to do it in the way that I think is easiest, but of course you could do it a different way, and that doesn't mean that it's wrong. So I'm going to change it to this. Okay, and now this is sort of like the previous problem. This is going to require a chain rule. Bring down the 1/2, keep the inside. 1/2 minus 2/2 is a -1/2. Now you need the derivative of the inside, which will be a quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, that's the answer for that. Okay, next is number 8. So if you wanted to go right into the quotient rule, you could, but then when you take the derivative of the top or the derivative of the bottom, you're going to have to deal with the product rule. I think you're better off multiplying this out. So you get x squared plus 2x minus 8 on top, and on the bottom you get x squared minus 9. Now it's just a simple quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, number 9. So first I'm going to change the form. So this becomes t to the negative 5/2 plus t to the 1/4 plus, I'm just going to keep radical 6 because when I take the derivative it's just going to be 0 anyway, so I'm not going to waste time changing that. Okay, so I'm going to take this negative 5/2 and multiply it by 3. That's going to give me negative 15/2. Keep the t. Negative 5/2 minus 2/2 is negative 7/2. Okay, now I'm going to take this 1/4, it's a simple power rule, and bring it down. So we get 1/4 t. 1/4 minus 4/4 is a negative 3/4. And of course the derivative of radical 6 is just 0. So that's your answer. Okay, now we go to the back of the page. Get a different color. Make it life exciting. Okay, there's number 10. Okay, so for the horizontal asymptote, we're looking at the highest degrees in the numerator and the denominator, so there's a 2 in each of them. So we're going to apply that rule that says that we're just going to use the coefficients. So there's a 1 here and a 1 here, so 1 over 1 is just 1. So there's a horizontal asymptote at y equals 1. You cannot write at 1. You'll get that wrong if you write that. It has to be at y equals 1. Okay, now we're going to look for vertical asymptote. So first we're going to take the denominator. And we're going to set that equal to 0. So we can factor. And we'll get x equals 3 and x equals negative 1. These are definitely discontinuities. Because if you look back at the original, in the denominator, x could never be 3 or negative 1 because then you'll get 0 in the denominator. The function will be undefined. So what you want to do is look at the numerator and denominator and wonder if you can factor anything. So that's what we're going to try and do. So the numerator can be factored as this, and we already know that the denominator can be factored as this. And now you can clearly see that nothing cancels at all. So if nothing cancels, then you can declare these as essential discontinuities. And if they are essential discontinuities, that means that there are also vertical asymptotes at that same place. Okay, and finally the last problem is number 11. And you're given a picture that looks something like this. Okay, this is at 3. this is 1, this is 2, and this is 3. Okay? So A says the limit as x approaches 3 from the left side. So as I approach 3 from the left side, I get 3. And that's what A says, so that is true. Then I go to B. The limit as x approaches 1, so 1 is right here. And so at the limit as I approach 1, so from the left and from the right, I would be right here, is the same thing as f of 1. Yes, that's true. Okay, C. The limit as x approaches 3 from the right side is 1. Yes, that's also true. Okay, D. Oh, it's a different color red. Says the limit as x approaches 3 exists. Well, that is definitely not true, because as I approach 3 from the left side, I'm up here. As I approach from the right side, I'm down there, so the limit does not exist. And therefore, D is the answer. And that's it. Good luck tomorrow.